Fact 1. We begin our observation in the industrial district of Shenzhen, specifically within the stacking yard, where the journey originates. Here, the primary unit of global trade, the intermodal container, sits in vast, geometric stillness, constructed from weathering steel, known technically as Core 10 steel. These rectangular structures are designed to develop a stable, rust-like appearance that protects the inner material from further corrosion. If one were to run a hand along the corrugated walls, one would feel the cool, oxidized texture of the metal, a surface that has been standardized to withstand the harsh, saline humidity of the maritime environment. The container is not merely a box. It is a resonant chamber currently empty, echoing with the low, distant hum of the port, waiting with infinite patience for the assignment of its cargo. This silence is the first step in a logistical chain. It values uniformity above all else. Fact 2. Drifting from the material composition to the dimensions that govern its existence, we consider the strict standardization of the 20-foot equivalent unit, or TEU. This measurement is the universal language of logistics, a bureaucratic constant that allows a box packed in a humid Chinese factory to slot perfectly into a chassis in a dry Nebraska rail yard without a single millimeter of friction. The corner castings, heavy blocks of reinforced steel located at the 8 corners of the prism, possess oval apertures designed to receive the twist locks of a crane. These apertures are identical on every container across the globe, a soothing repetition of form that ensures that no matter where the object travels, it will always fit, it will always lock, and it will always remain secure within the grid of global commerce. Fact 3. As the container is designated for transport, the loading process commences, not with haste, but with a methodical hydraulic rhythm. A rubber-tired gantry crane, a towering structure of steel lattice, positions itself above the stack with a slow, deliberate grace. The spreader bar descends, guided by the steady hand of an operator and the pull of gravity, until the metallic clank of the twist locks engaging with the corner castings reverberates through the yard. There is a hiss of pneumatic pressure as the container is lifted, hovering momentarily in the gray industrial air before being lowered onto a waiting skeletal trailer. This transfer is seamless, a testament to the predictable physics of the supply chain, where heavy objects float from one mode of transport to another with the lethargy of a drifting cloud. Fact 4. While the physical container begins its slow movement toward the quay, a parallel journey begins in the realm of paper and ink. This is the creation of the Bill of Lading, a document of immense legal weight that acts as the receipt, the contract of carriage, and the document of title. In a quiet, fluorescent-lit office, a clerk inputs the alphanumeric identification code painted on the container's door, 4 letters followed by 7 numbers. This code is the container's singular identity among millions. The data is transmitted through digital conduits, a silent stream of information that mirrors the physical movement of the steel box. The bureaucratic process is slow, requiring verification and countersignatures, a layered accumulation of permissions that ensures nothing moves without the heavy anchor of authorization. Fact 5. The container now arrives at the terminal, where it meets the vessel that will carry it across the Pacific, a Panamax-class container ship. This vessel is a floating city of steel, designed not for speed, but for displacement and stability. It sits low in the water, its hull painted a dull, anti-fouling red, submerged beneath the waterline where it interacts with the density of the ocean. The ship does not bob, it displaces, pushing thousands of tons of water aside to create a void that it then occupies. The sheer scale of the vessel renders it almost static to the human eye, a massive, monolithic island that absorbs the small, rhythmic lapping of the harbor waves against its side, waiting to receive tier after tier of standardized cargo. Fact 6. The stacking of the vessel is a study in vertical integration and weight distribution. Our container is not placed randomly. It is slotted into a cellular guide rail system, a steel framework within the ship's hull that prevents lateral movement. It slides down into the darkness of the hull, coming to rest atop another identical container, metal meeting metal with a dull thud that vibrates through the ship's keel. As more containers are stacked above it, the light is gradually extinguished, leaving our unit in a permanent, cool twilight. Here, in the belly of the ship, the air is still, smelling of oil and salt, as the container becomes a single brick in a wall of 10,000 others, locked in a state of suspended animation. Fact 7. As the vessel departs Shenzhen, the transition is imperceptible, marked only by the deep, resonant vibration of the diesel engines coming to life. These are massive, slow-speed engines, turning at perhaps only 100 revolutions per minute, producing a rhythmic, infrasonic thrum that penetrates every piece of steel on the ship. The shoreline, with its cranes and lights, begins to recede, dissolving into the atmospheric haze. The ship does not cut through the water so much as it pushes the ocean ahead of it, moving at a steady cruising speed of 12 knots. This is the beginning of the blue water phase, where the visual complexity of the land is replaced by the monotony of the open ocean, a flat gray horizon that stretches endlessly in all directions. Fact 8. Navigating the Great Circle Route towards North America, the ship enters a zone of profound isolation. For days, the view from the bridge remains unchanged, a 360-degree panorama of water meeting sky. The container, buried deep within the stack, is subjected to the slow, rolling motion of the Pacific swells. This is not a violent tossing, but a long, pendulous sway, a rhythmic tilting of the horizon that occurs over periods of 10 to 15 seconds. The internal cargo, packed tight and secured with dunnage bags, shifts imperceptibly with the roll, a silent adjustment to the curvature of the earth. The ship is a solitary point of order in a chaotic, natural world, maintaining its heading with the unyielding logic of a gyroscope. Fact 9. To maintain this equilibrium amidst the shifting weight of fuel consumption and ocean currents, the ship utilizes a complex system of ballast tanks. Deep beneath the containers, seawater is pumped into or out of specific chambers in the double hull. This process is slow and liquid, the sound of water rushing through the pipes the only variation in the ship's auditory landscape. The ballast water lowers the center of gravity, countering the buoyancy that seeks to lift the ship. It is a constant, fluid balancing act, ensuring that despite the height of the container stacks, the vessel remains upright and steady, dampening the roll, keeping the cargo in a state of artificial calm as it traverses the abyss. Fact 10. After weeks of this rhythmic solitude, the journey pauses at the approach to the port of Long Beach. The ship does not dock immediately. Instead, it enters the anchorage, a designated parking lot in the sea. The massive anchor chain is released, rattling through the hawsepipe link by heavy link until it finds purchase in the seabed far below. The engine is cut, and the deep vibration ceases, replaced by the sound of wind over steel and the distant, muffled cry of a gull. The container waits once more, suspended between the origin and the destination, held in the quiet purgatory of the logistics queue, viewing the distant, twinkling lights of the California coast through the salt spray, waiting for the slow bureaucracy of customs to grant it entry. Fact 11. The stillness of the anchorage is eventually broken, not by the ship's own power, but by the arrival of the harbor pilot. This specialized navigator approaches in a small, nimble cutter that pulls alongside the massive red steel hull of the container ship. The transition of authority is a slow, physical process. The pilot must climb a rope ladder, drop down the side of the vessel, a solitary figure ascending a cliff of painted metal. Once on the bridge, the pilot issues quiet, monosyllabic commands to the helm, guiding the vessel through the narrow, dredged channels of the harbor. The ship moves with glacial slowness, aided by tugboats that nudge its flank with padded bows, gently forcing the thousands of tons of displacement towards the concrete quay. The water churns lazily, a brown foam created by the reverse thrust of the propellers as the behemoth finally comes to rest against the rubber fenders of the dock. Fact 12. Now docked, the vessel sits beneath the looming shadows of the ship-to-shore STS cranes. These structures are the giants of the port, A-frame skeletons of steel that tower hundreds of feet into the salt air. The operator sits in a glass cab suspended high above the deck, looking down through a transparent floor at the grid of containers below. The operation is a study in pendulum physics. The spreader bar descends on long, thick cables, swaying slightly in the coastal breeze before stabilizing. There is a precise mechanical intimacy as the spreader aligns with our container. Twist locks descend into the corner castings, rotating 90 degrees with a muffled, metallic thunk that signals a positive lock. Then, with the groan of electric winches, the container is lifted from its resting place, rising slowly out of the ship's hold and into the bright, hazy sunlight of California. Fact 13. Suspended in the air, the container travels horizontally along the boom of the crane, crossing the threshold between the sea and the land. It hovers momentarily over the bomb cart, a specialized skeletal trailer designed solely for terminal transport. Before descending, the landing is not a crash, but a controlled settlement. The steel of the container meets the steel of the chassis with a deep, resonant vibration that shudders through the frame. The twist locks on the trailer are not yet engaged. Gravity alone holds the box in place for this short transit. The terminal tractor, a small, snub-nosed truck with an elevated cab, engages its gear, and the unit begins to move away from the water, rolling on solid rubber tires across the vast paved expanse of the container terminal, surrounded by thousands of identical metal boxes stacked in neat, colorful rows. Fact 14. The journey through the terminal is a navigation of the stack, a labyrinth of logistics where computers determine the optimal location for every unit. Our container is not destined for a long stay in the yard, but is flagged for drayage, the short-haul transport to the railhead. The tractor joins a queue of idling vehicles, a line of engines humming in a low collective drone. The air here smells of diesel exhaust and warmed asphalt. It is a place of waiting. Drivers sit in their cabs, checking paperwork, while the sun beats down on the metal roofs. The movement is incremental, a slow creeping forward measured in feet as each truck passes through the optical character recognition OCR portals. These scanners read the container number automatically, logging its presence on American soil without a single human word being spoken. Fact 15. Before leaving the secure zone, the container must undergo a non-intrusive inspection, NII. It is driven slowly through a large arch-like structure that houses a gamma ray or X-ray imaging system. The process is silent and invisible. Inside the container, the waves of radiation pass through the steel walls and the cargo within, creating a ghostly, gray-scale density map on a screen in a remote, darkened room. The analyst looks for anomalies, shadows that do not match the declared manifest of consumer electronics or textiles. There is no opening of doors, no breaking of seals. The container remains a hermetically sealed vault, its secrets examined by the cold logic of high-frequency wavelengths, cleared for entry by a digital stamp of approval that allows the gate arm to lift. Fact 16. Leaving the port complex, the truck navigates the heavy industrial infrastructure of the Intermodal corridor. This is a dedicated roadway, sunk below the level of the city to dampen the noise, a concrete canyon built specifically for the movement of freight. The container travels a short distance to the Intermodal Container Transfer Facility, ICTF. Here, the mode of transport shifts from rubber tire to steel wheel. The truck enters the rail yard, a dusty, sprawling expanse of parallel tracks that gleam in the afternoon sun. The scale of operations shifts again. The vehicles here are reach stackers, massive mobile cranes with telescopic booms that prowl the yard like prehistoric beasts, lifting containers with hydraulic ease to prepare them for their transcontinental voyage. Fact 17. The transfer to the train utilizes a wide-span rail-mounted gantry crane. Our container is lifted once more, but this time it is positioned over well car. These specialized rail cars are designed with a depressed center, allowing the container to sit low between the bogies, the wheel sets, merely inches above the tracks. This design is crucial for the double-stack efficiency that defines American rail logistics. Our container is placed into the well, serving as the foundation. The crane then retrieves a second container, perhaps one filled with furniture or auto parts, and lowers it directly on top of ours. The four corner castings meet again, interconnected by small cast iron devices called IBCs, inner box connectors, effectively welding the two boxes into a single two-story block of freight. Fact 18. The train itself is being assembled, a process known as building the consist. It is an immense, linear structure, often stretching nearly 2 miles in length. The coupling of the cars is a mechanical handshake. The heavy steel knuckles of the couplers slide into each other and lock automatically. Following the mechanical connection is the pneumatic one. Carmen, railway workers in high visibility vests, walk the length of the train, connecting the air hoses between each car. As the locomotives at the front charge the system, a wave of air pressure travels down the 2-mile pipe. You can hear the brakes releasing sequentially, a cascading series of hisses and clicks that travels from the front of the train to the rear, signaling that the metallic snake is waking up. Fact 19. At the head of this 2-mile chain are the locomotives, usually 3 or 4 diesel-electric engines, linked in multiple. They do not drive the wheels directly. Rather, a massive diesel engine turns a generator, which produces electricity to power traction motors on the axles. This transmission of power is smooth and incredibly strong. As the engineer applies the throttle, the amperage rises, and the magnetic fields in the motors engage. There is no sudden lurch. The train begins to move with an imperceptible creep, the slack in the couplers stretching out car by car. The steel wheels grind against the steel rails, producing a high-pitched, singing harmonic that is characteristic of heavy rail, a sound that rises in pitch as the train slowly gathers momentum, pulling thousands of tons of dead weight into motion. Fact 20. The train departs the Los Angeles basin, heading east towards the Alameda corridor, and eventually the Cajon Pass. The scenery transitions from the concrete geometry of the industrial yards to the arid scrub brush hills of the high desert. The speed is constant and rhythmic, governed by the click-clack cadence of the wheels passing over rail joints. The container, buried at the bottom of the double stack, is now a passive traveler in a steel canyon. It passes through suburban crossings, where the bells of the warning gates provide a Doppler-shifted chime, and into the silence of the Mojave. As night falls, the only light comes from the locomotive's headlight, cutting a cone through the darkness, pulling the container into the vast, empty interior of the continent, rocking it gently to the rhythm of the rails. Fact 21. As the train begins its ascent through the Cajon Pass, the physics of the journey shift from momentum to raw, tractive effort. The grade here is steep, a 2.2% incline that demands the absolute limit of the diesel electric engines. To prevent the steel wheels from slipping on the steel rails under such immense strain, the locomotives automatically deploy sand from internal reservoirs. This silica is blown onto the tracks directly in front of the wheels, a gritty, sacrificial layer that is crushed into dust to provide the necessary friction. The sound of the engines deepens into a resonant, chest-vibrating drone, a constant, unwavering frequency that signifies the struggle against gravity. The train moves at a walking pace, a slow, heavy snake winding through the geological folds of the mountains, the container tilting slightly as the track banks into the long, sweeping curves of the ascent. Fact 22. Having conquered the summit, the consist descends into the high desert, entering a landscape defined by its vacuum of human presence. The heat here is visible. It rises from the ballast stones in shimmering waves that distort the air, making the distant mountains appear fluid and insubstantial. Inside the container, the temperature rises steadily, the air becoming stifling and dry, baking the cardboard packaging of the cargo within. The train moves through this thermal tunnel for hours without passing a single structure, a solitary line of geometry cutting through the organic chaos of scrub brush and sand. The sense of time dilates in this emptiness. There are no landmarks to mark progress, only the repetitive flash of telegraph poles passing the window, a metronomic counting of distance that stretches into the horizon. Fact 23. Efficiency on a single track line dictates that one train must occasionally yield to another, a logistical pause known as the meet. Our train slows and diverts onto a siding, a parallel length of track designed for waiting. Here, the motion ceases entirely. The silence that follows the shutdown of movement is profound, broken only by the ticking of cooling metal and the wind hissing through the gaps between the containers. For 40 minutes, the cargo sits motionless in the desert, a paused frame in a moving picture. Eventually, the opposing train appears as a speck in the distance, growing gradually into a roaring wall of steel that passes with a violent rush of air, shaking the ground before disappearing, allowing the signal light to flicker from red to green, granting permission to resume the slow drift eastward. Fact 24. As the sun dips below the horizon, the visual world recedes, replaced by the auditory landscape of night travel. The train activates its headlights, casting a solitary, piercing cone of illumination that reveals only the immediate future of the tracks. The darkness wraps around the container, erasing the context of the outside world. Without the visual cues of speed, the sensation of movement becomes purely rhythmic. The wheels hum against the rails, a sound that is not a clatter but a continuous, high-pitched shh caused by the friction of rolling steel. Inside the cab, the glow of the instrument panel provides a dim, green luminescence, the only light for miles, creating a cocoon of technology moving through a void of natural darkness. Fact 25 morning reveals a dramatic shift in topography as the train crosses into the Great Plains. The rugged, vertical interruptions of the mountains have been ironed out into a flatness that defies perspective. The horizon is a perfect, uninterrupted line, separating the pale blue of the sky from the golden brown of the agricultural expanse. The train is now a tiny thread on a vast quilt of corn and soy. We pass irrigation pivots, massive skeletal sprinklers that rotate on wheels with agonizing slowness, creating perfect circles of green in the earth. The repetition is hypnotic. Mile after mile of identical fields, identical fences, and identical utility poles pass by, a visual mantra that lulls the brain into a state of passive observation, requiring no analysis, no reaction, only witnessing. Fact 26. The smoothness of this ride is owed to the engineering marvel of continuous welded rail CWR. Unlike the tracks of the 19th century, which were disjointed segments bolted together, modern rails are welded into ribbons that stretch for miles without a break. This eliminates the rhythmic click-clack of the past, replacing it with a fluid, gliding sensation. The steel rails expand and contract with the ambient temperature, breathing with the day and night. To prevent them from buckling under the heat of the planes, they are anchored to heavy concrete ties with spring clips that look like curled fingers of steel. Our container floats over this seamless path, the vibration minimized to a gentle, consistent tremor that is felt rather than heard, a physical lullaby generated by the interface of wheel and rail. Fact 27. Approaching the massive classification yards of Nebraska, the train begins the long, gradual process of deceleration. This is not achieved by brake pads clamping down, which would incinerate under the heat, but through dynamic braking. The engineer reverses the polarity of the traction motors, turning them into massive electrical generators. The momentum of the train spins the motors, generating resistance that drags against the wheels. The energy produced is dissipated as heat through large resistor grids on the roof of the locomotive, heralded by the rising whine of cooling fans. The train feels heavy again, the slack bunching up as the cars bump gently into one another, the kinetic energy of thousands of miles bleeding away into the atmosphere as the velocity drops to a crawl. Fact 28. We arrive at the outskirts of the rail hub, a sprawling city of tracks that looks from the air like a metallic river delta. This is the point of disaggregation. The train, which has existed as a single unit for 2,000 miles, is about to be unmade. It pulls into the receiving yard, coming to a final, squealing halt. The silence returns, heavier now than in the desert. Men in orange vests walk the length of the gravel ballast, performing the manual labor of disconnection. The air hoses are separated with a sharp hiss of escaping pressure. The steel knuckles of the couplers are pulled open. Our container, still sitting in its well car, is now isolated from the locomotives that brought it here, sitting stationary in a sea of parallel tracks, waiting for the next phase of sorting. Fact 29. The car carrying our container is pushed by a switching engine towards the hump, a small artificial hill that serves as the heart of the sorting mechanism. This process uses the most reliable engine on Earth, gravity. As the car crests the top of the hump, it is uncoupled and allowed to roll freely down the other side. It drifts silently, a ghost car moving under its own weight, a computer calculating the weight and speed of the car, remotely switches the tracks ahead of it. The car navigates the labyrinth of rails, turning left, then right, guided by invisible hands, rolling slowly until it gently impacts and couples with a new line of cars destined for the local Intermodal ramp. It is a slow, mesmerizing dance of heavy machinery, performed without human drivers. Fact 30. Finally, the rail journey concludes at the Intermodal terminal. The container is positioned beneath a rubber-tired gantry crane, similar to the one in Shenzhen, but smaller, more specific to this inland geography. Clamps engage, and the container is lifted out of the well car, suspended once more in the air. It hovers over the concrete, water dripping from its underside, before being lowered onto a waiting skeletal chassis attached to a semi-truck. The lock pins click into place. The container is now returned to the rubber tire ecosystem. It sits in the parking lot of the rail yard, surrounded by the smell of prairie grass and diesel, a stationary steel box among thousands, waiting for the final short haul to the distribution warehouse. Fact 31. The final transfer of custody begins with the arrival of the drayage driver, a local operator whose domain is the short, repetitive radius between the rail ramp and the warehouse district. He backs his truck under the chassis where our container rests. The connection is a mechanical marriage of kingpin and fifth wheel. He reverses slowly until the steel pin on the chassis slides into the greased, horseshoe-shaped coupling device on the back of the truck. The spring-loaded jaw snaps shut around the pin with a sharp, definitive clack. The driver steps out to connect the glad hands, the coupling heads for the air brakes. He presses the red and blue seals together and twists them downwards, completing the pneumatic circuit that allows truck's air system to breathe life into the trailer's brakes. Fact 32. Leaving the rail yard, the truck enters the highway, merging into the flow of traffic. The environment here is one of concrete and logistics parks. The scenery is repetitive, endless rows of tilt-up concrete warehouses, each painted in neutral shades of beige or gray, distinguished only by the small numbers painted on their loading docks. The road is flat and straight, designed for the turning radius of 53-foot trailers. The tires hum on the pavement, a steady, low-frequency drone that resonates through the cab. The driver shifts gears, the engine revving and falling in a predictable, rhythmic cycle as the heavy load is pulled against the resistance of the air. It is a journey of minimal variation, a straight line drawn between 2 points of commerce. Fact 33. The truck arrives at the distribution center, a massive, rectangular structure that spans several acres. The driver stops at the guard shack, a small glass booth at the entrance. Here, the bureaucratic ritual repeats. Clipboards are exchanged. The seal number on the back of the container, a small metal strip that has remained unbroken since Shenzhen, is verified against the digital manifest. The guard waves the truck through, and the vehicle moves slowly towards the dock doors. The building is surrounded by a vast apron of concrete, stained with oil and tire marks, a staging ground for the constant circulation of goods. The truck maneuvers into position, executing a slow reverse arc to align the rear of the container with dock door 42. Fact 34. The docking process is an exercise in precision. The driver watches his mirrors, guiding the 53-foot trailer backward with inch-perfect accuracy. The rear of the container approaches the rubber bumpers of the dock wall. As it makes contact, the entire warehouse structure absorbs the gentle impact. The air brakes hiss as they are engaged. The driver chocks the wheels, placing heavy rubber wedges in front of the tires to prevent rolling. Inside the warehouse, a dock leveler, a hydraulic steel plate, rises from the floor and extends outward, bridging the gap between the concrete building and the wooden floor of the container. It descends with a clang, creating a continuous path for the forklifts to enter. Fact 35. The breaking of the seal is the final act of the container's journey as a secure vessel. A warehouse worker approaches with a large pair of bolt cutters. The metal strip, which has rusted slightly from the salt air of the Pacific, is snipped. The steel doors, stiff from weeks of travel, are unlatched. The long metal bars are rotated, cams disengaging from their keepers, top and bottom. With a groan of hinges, the doors swing open, releasing a pocket of stagnant air that has been trapped inside since China. The interior is dark, illuminated only by the sudden rectangle of light from the open dock door. The cargo, stacked on wooden pallets and wrapped in clear plastic, sits exactly where it was placed, silent and undisturbed. Fact 36. The unloading begins with the electric forklift, a quiet battery-operated machine that whirs softly as it moves. The operator drives onto the dock leveler, the solid rubber tires rumbling over the steel plate. He enters the container, the mast of the forklift tilting back slightly to cradle the first pallet. The forks slide into the wooden slots with a scraping sound. The hydraulic lift engages, raising the load a few inches off the floor. The forklift reverses, backing out of the steel box and into the cavernous space of the warehouse. The motion is repetitive. Enter, lift, reverse, exit. Pallet by pallet, the container is empty, the void growing larger until the ribbed steel floor is bare, sweeping clean the space that was once full. Fact 37. Once the goods are on the warehouse floor, they enter the receiving phase. A worker with a handheld scanner approaches the pallets. He aims the laser at the barcode on the side of a box. A red line traces the black stripes, and a high-pitched beep confirms the data. This beep is the digital handshake that transfers the inventory from in transit to on hand. The system updates instantly, a ripple of data moving through servers to confirm that the items have arrived. The worker applies a new label, license plate, for the warehouse's internal logic, designating exactly where this pallet will live until it is needed. The process is methodical, a slow accounting of physical objects. Fact 38. The forklift driver now takes the pallet deeper into the warehouse, driving down the main aisle. The scale of the building becomes apparent here. The ceiling is 30 feet high, supported by steel trusses that disappear into the gloom above. To the left and right are the racking systems, towering skeletons of orange and blue steel that stretch endlessly into the distance. The air is cool and smells of cardboard and dust. The only sounds are the distant beep of other scanners and the hum of the electric motors. The driver navigates this grid with practiced ease, turning down aisle 14, a narrow canyon formed by walls of boxed inventory that rise vertically like cliffs on either side. Fact 39. The pallet is destined for a high bay location, a slot near the top of the racking. The forklift stops in front of the empty space. The operator pulls a lever, and the mast begins to extend. It rises slowly, the hydraulic cylinder telescoping upward. The chain rattling against the metal guides is a steady, climbing sound. The pallet ascends past level 1, level 2, level 3, floating higher into the dimly lit upper reaches of the warehouse. The driver tilts his head back, watching through the overhead guard. At 20 feet in the air, the motion stops. The forklift creeps forward, the pallet sliding gently onto the wire mesh deck of the rack. The forks lower slightly to disengage, and the machine backs away, leaving the cargo suspended in its new home. Fact 40. With the pallet stored, the cycle is complete. The warehouse returns to its baseline state of quiet activity. The lights in the aisle are motion activated. As the forklift drives away, the illumination behind it flickers off section by section, plunging the aisle back into darkness. The cargo sits high on the shelf, wrapped in its protective plastic cocoon, resting in the cool, silent air. It has traveled 7,000 miles, moved by crane, ship, train, and truck to reach this precise coordinate of stillness. It is no longer moving. It is simply there, a static object in a vast, organized library of things, waiting in the dark for the next command, which may not come for months. Fact 41. While the pallet rests in the darkness of the high bay, its identity is maintained by a series of vertical black lines known as the UPC, or Universal Product Code. This system of identification was not born from digital complexity, but from a desire to automate the mundane checkout lines of grocery stores in the mid-20th century. The code is a binary language of light and dark. The scanner emits a red laser beam, which is absorbed by the black bars and reflected by the white spaces. The sensor measures the varying duration of the reflection as the beam sweeps across, translating the physical contrast into a digital string of numbers. It is a language spoken entirely in silence, a Morse code of commerce that requires no translation, only the steady, red gaze of a laser to be understood. Fact 42. The specific variant used in logistics is often the code 128, a high-density linear barcode capable of encoding all 128 characters of the ASCII set. Unlike the simple consumer barcode on a box of cereal, code 128 is a robust data carrier. It includes a checksum digit at the end, a mathematical failsafe calculated from the preceding numbers. When the scanner reads the code, it instantly performs the calculation. If the result does not match the checksum digit, the scanner refuses to beep. This prevents errors caused by smudged ink or torn labels. It is a self-correcting system, a tiny algorithmic guardian, ensuring that a box of automotive parts is never mistaken for a box of textiles. regardless of how tired the human operator might be. Fact 43. The concept of tracking inventory predates the laser by millennia, finding its roots in the clay tablets of ancient Mesopotamia. In the temples of Uruk, scribes used a stylus to press wedge-shaped marks into wet clay, recording the movement of grain, sheep, and beer. These tablets were the original spreadsheets, the first attempt to impose order on the chaos of material possession. They were allowed to dry in the sun, baking the data into a permanent record that could survive for centuries. The modern warehouse management system is the direct descendant of these clay tablets, replacing the stylus with the keyboard and the sun-baked clay with the silicon chip, but the fundamental purpose remains unchanged: to know with absolute certainty what is owned and where it lies. Fact 44. In the quiet aisles of the warehouse, the air is often kept at a specific humidity to preserve the integrity of the corrugated cardboard boxes. Cardboard, or more technically, corrugated fiberboard, is a material of surprising engineering sophistication. It consists of a fluted sheet of paper, the medium, sandwiched between two flatliners. The flutes act as a series of connected arches, the strongest architectural shape known to man, providing immense vertical strength while remaining lightweight. A single box can support hundreds of pounds of weight stacked above it, provided the humidity does not soften the paper fibers. The warehouse is thus a climate-controlled cathedral dedicated to the structural integrity of paper, keeping the air dry enough to ensure the stacks do not collapse under the weight of their own geometry. Fact 45. The pallet itself, the wooden platform upon which the cardboard rests, is a standardized unit measuring 48 inches by 40 inches in the United States. This is the GMA pallet, established by the Grocery Manufacturers Association. It is constructed from stringers and deckboards, usually made of oak or southern yellow pine. The wood is often rough-hewn, bearing the knots and grain of the tree it once was. Before entering the global supply chain, these wooden platforms must be heat-treated to kill any invasive insects living in the grain. They are baked in a kiln until the core temperature reaches 56 degrees Celsius for 30 minutes. This invisible sterilization allows the wood to cross international borders without carrying ecological contraband, a silent passport stamp burned into the timber. Fact 46. Drifting deeper into the mechanics of storage, we consider the picking process. When an order is received, the warehouse management system calculates the most efficient route for the worker to travel, a variation of the famous traveling salesman problem. The algorithm plots a path that minimizes footsteps, creating a serpentine route through the aisles. The worker does not choose where to go. They follow the instructions on a wrist-mounted terminal. The device directs them to aisle 4, bay 12, level 1. It is a choreography of efficiency, where human movement is dictated by mathematical logic, turning the chaotic act of gathering items into a smooth, linear progression through the grid of shelves. Fact 47. In modern, automated warehouses, the human element is removed entirely, replaced by the silent glide of SRS or automated storage and retrieval systems. These are robotic cranes that run on tracks fixed to the floor and ceiling of the aisle. They move with a terrifying speed and silence, zipping horizontally and vertically, simultaneously to retrieve a tote. There are no lights in these sections of the warehouse. The robots do not need to see. They navigate by counting wheel rotations and reading barcodes on the racking. It is a dark warehouse, a space of pure machine activity, where the only sound is the electric whir of servo motors and the click of solenoids operating in a pitch-black void of perfect productivity. Fact 48. The data generated by these movements flows into the ERP, the Enterprise Resource Planning System. This software is the central nervous system of the corporation, a massive database that records every transaction in real time. When a pallet is moved, the ERP adjusts the balance sheet, moving assets from inventory to cost of goods sold. It is a continuous, automated accounting process. The physical movement of the box triggers a financial movement in the ledger. The digital and the physical are lockstep. A forklift turning a corner in Nebraska causes a number to change on a server in Virginia. The butterfly effect of logistics, where every physical action has an immediate digital reaction. Fact 49. Let us pause to consider the floor of the warehouse itself. It is not ordinary concrete. It is super flat concrete, poured with laser-guided screens to ensure that the variance in elevation is less than a fraction of an inch over hundreds of feet. In a warehouse with 40-foot-high racks, a bump of a quarter inch on the floor could cause the forklift mast to lean inches to the side at the top, potentially causing a collision. The floor is polished to a mirror shine, sealed with hardeners to prevent dust. It is a vast gray ice rink of stone, designed to offer zero resistance to the hard rubber wheels of the material handling equipment, a surface of perfect, unnatural flatness. Fact 50. Finally, we contemplate the dust that inevitably settles on the highest racks, where human hands rarely reach. In the stillness of the high bay, suspended 20 feet in the air, time moves differently. A pallet may sit here for months, known as slow-moving inventory, a fine layer of gray particulate matter composed of paper fibers, concrete dust, and microscopic debris slowly coats the plastic wrap. It is geological sedimentation on a micro scale. The dust is the only thing that changes in this static environment, a soft gray blanket that accumulates in silence, marking the passage of time in a place designed to eliminate it, a gentle reminder of entropy in a system of rigid order. Fact 51. Upon leaving the high bay warehouse, the package enters the hub and spoke network, a logistical geometry designed to minimize distance through the maximization of centralization. The parcel is not driven directly to the recipient. Rather, it is inducted into a massive regional sortation facility, a building that functions as a mechanical heart. These facilities are vast, often spanning millions of square feet, yet they are devoid of human inhabitation in the traditional sense. They are machines designed for boxes. The air within is filled with the hum of electric motors and the low rumble of rollers. The package travels on a belt that moves at a constant hypnotic speed of 300 feet per minute, joining a river of brown cardboard that flows endlessly through the steel arteries of the building, a silent, continuous stream of commerce moving towards the inevitable sorting logic. Fact 52. The primary mechanism of sorting is the cross-belt sorter, a sophisticated loop of individual carriages that ride on a track suspended above the floor. Each carriage carries a single package, holding it like a ceremonial offering. As the carriage reaches the specific chute designated for a particular zip code, a small motorized belt on the carriage itself activates. It spins for a fraction of a second, gently sliding the package sideways off the track. The motion is smooth and lateral, a precise ejection that sends the box tumbling down a spiral slide. This slide, made of polished fiberglass, uses gravity to decelerate the package, allowing it to spiral downward in a slow corkscrew motion until it reaches the loading dock level, landing softly among its geographic peers. Fact 53. Before the package can be sorted, it must pass through the scanning tunnel, a dedicated archway of red light and mirrors. Here, 5-sided barcode scanners read the label from every conceivable angle simultaneously. The red lasers crisscross the belt in a dense web of light, ensuring that even if the box is upside down or rotated, the code is captured. This happens in milliseconds, yet to the machine, it is a deliberate process of identification. If the scanner fails to read the code, perhaps due to a wrinkled label or a smudged bar, the belt does not stop. Instead, a diverter arm gently nudges the no-read package onto a separate hospital line, a quiet spur of the conveyor where packages go to be healed, manually inspected and relabeled by a human hand in a slow corrective ritual. Fact 54. The loading of the final delivery vehicle utilizes a telescopic boom conveyor, a specialized piece of equipment that extends like a mechanical tunnel directly into the back of the delivery van. The loader does not need to walk back and forth. The belt brings the boxes to them, extending further into the truck as the space fills. The stacking order here is dictated by LIFO, last in, first out. The packages, destined for the end of the route, are placed at the very back of the truck, buried deep behind the wall of earlier deliveries. It is a physical timeline of the coming day, constructed in reverse, a wall of cardboard that will be slowly deconstructed over the course of 8 hours, revealing the depth of the vehicle as the sun travels across the sky. Fact 55. The vehicle itself, often referred to as a step van, is a masterpiece of utilitarian design, stripped of all comfort in favor of pure function. The doors are not hinged. They slide backward into the body of the truck, allowing the driver to enter and exit without the obstruction of a swinging metal sheet. The floor is made of diamond plate aluminum, durable and non-slip, which amplifies the sound of boots stepping in and out. The seat is high and stiff, providing a commanding view of the suburban landscape. The engine is often a durable, low RPM diesel or a quiet electric motor designed for thousands of stop-start cycles. It does not speed. It lumbers, a reliable beast of burden that moves with a heavy, deliberate momentum through the residential streets. Fact 56. The route the driver follows is not a product of human intuition, but the output of a dynamic routing algorithm. This software solves a complex mathematical puzzle every morning, calculating the most efficient path to connect 150 distinct points. It prioritizes right-hand turns to avoid the delay of waiting for oncoming traffic, creating a route that loops in varying spirals rather than straight lines. The driver is merely the executor of this digital logic, following a blue line on a screen that dictates every turn, every stop, and every pause. The freedom of the open road is replaced by the comfort of absolute certainty. There is no need to decide, only to obey the gentle, turn-by-turn voice of the guidance system. Fact 57. As the vehicle moves through the neighborhood, it creates a specific auditory signature that signals its presence. The sound is not the roar of a highway truck, but the distinct, rhythmic rattle of the roll-up rear door vibrating in its tracks. There is the high-pitched squeal of the brakes as the heavy chassis comes to a halt at a curve. Then, the unique mechanical whir clunk of the electronic parking brake engaging. Finally, the silence of the engine cutting off. This sequence, rattle, squeal, whir, silence, repeats over and over, a percussive rhythm that measures out the afternoon in 3-minute intervals, a sound that becomes part of the background static of the suburban environment. Fact 58. The driver carries a handheld device, often called a rabbit or a scanner, which serves as the digital tether to the central network. Upon reaching the doorstep, the driver scans the package one final time. This stop-complete scan is the definitive end of the logistical chain. The device emits a chirp, a sound that signifies the transfer of legal custody from the corporation to the consumer. The GPS coordinate of the scan is logged, pinpointing the exact location of the delivery to within 3 meters. It is the final data point in a journey that began in Shenzhen, a digital period placed at the end of a long transoceanic sentence. Fact 59. The placement of the package on the porch is an act of liminal stillness. The driver sets the box down on the concrete or the welcome mat, orienting the label upwards. He or she may take a photograph, a proof of delivery, which captures the box in its final resting place, often framed by the mundane details of a potted plant or a peeling door frame. The driver then turns and walks away. The package is left alone. It sits there, a brown rectangular object in the quiet afternoon light, waiting for the door to open. It has transitioned from being a unit of freight, moving constantly at high speed, to being a domestic object, stationary and silent, resting on the threshold of private life. Fact 60. Finally, we consider the afterlife of the packaging itself, the corrugated box that has served as the protective shell for thousands of miles. Once opened, its purpose is fulfilled. It is flattened, the tape sliced, the structure collapsed back into a two-dimensional sheet. It enters the recycling bin, beginning a new, slower loop. It will be collected, pulped, and reformed into a new box, a cycle of reincarnation that occurs without fanfare. The fibers of the paper remember the stress of the journey, becoming slightly shorter and weaker with each recycling, a gradual molecular fatigue that mirrors the slow, steady entropy of the universe, fading gently into the background of the material world. Fact 61. While the physical container moves, it is shadowed by a ghost of pure liability, known as general average. This ancient maritime law, codified in the York-Antwerp rules, dictates that if a ship is in peril and cargo must be sacrificed to save the vessel, perhaps jettisoned into the sea during a storm, all parties with cargo on board must share the financial loss proportionally. It is a concept of communal risk that dates back to the Rhodians of antiquity. The calculation of this contribution is not immediate. It is a slow, forensic accounting process that can take years to finalize. Adjusters in quiet offices in London or Singapore sift through manifests and valuation declarations, balancing the ledger of sacrifice long after the waves have settled, ensuring that the burden of disaster is distributed with mathematical precision across the collective. Fact 62. The container itself is rarely owned by the shipping line that carries it. Instead, it is often the property of a leasing company, a financial entity that deals in steel boxes as asset classes. These companies exist in a realm of pure capital efficiency. A container may be built in China, leased to a Danish shipping line, subleased to a Korean logistics firm, and finally returned to a depot in New Jersey. The ownership title is a digital certificate that floats above the physical object. The lease agreements are detailed documents specifying per diem rates, pennies per day, that accumulate silently. It is a rental market of millions of units, where revenue is generated not by the excitement of trade, but by the slow, steady tick of daily usage fees accumulating on a balance sheet. Fact 63. When a container is returned to a depot, it undergoes the IICL inspection, governed by the Institute of International Container Lessors. This is a study in dull geometric tolerance. An inspector walks around the box with a specialized ruler and a flashlight. They measure dents. The dent in the side panel is acceptable if it is less than 35 millimeters deep. If it is 36 millimeters, it requires repair. The floor is checked for delamination, the separation of the plywood layers. It is a binary assessment of wear and tear. The inspector marks the steel with yellow chalk, circling the imperfections. These chalk circles are the only commentary on the container's history, a silent language of damage assessment that dictates whether the box will sleep in the repair yard or return to the sea. Fact 64. The repair process itself is a slow craft of welding and patching. In the hot work area of the depot, a welder cuts out a damaged section of the core 10 steel. The sound is a steady hiss of the cutting torch, followed by the clatter of the falling metal. A new patch, pre-cut to the exact dimensions, is fitted. The welding arc crackles, fusing the new steel to the old. The heat radiates through the metal wall, expanding it slightly. Once cooled, the patch is painted. The color matches were rarely perfect. The new paint is bright and glossy, standing out against the faded, sun-bleached industrial blue of the original wall. It is a visual scar, a patch of freshness on a weathered body, sealing the vessel once more against the intrusion of salt and water. Fact 65. Let us consider the tear weight, the weight of the empty container. For a standard 20-foot unit, this is approximately 2,200 kilograms. This number is painted on the door of every container in white, block letters, tear. It is a constant deduction in the equation of shipping. Every crane that lifts a container, every ship that carries it, and every truck that pulls it is expending energy to move this dead weight. It is the price of structure. Engineers spend lifetimes trying to shave kilograms off this number, optimizing the corrugation profile of the walls to maintain strength while using less steel. It is a game of diminishing returns, a quest for lightness in an industry built on heavy metal. Fact 66. The floor of the container, the plywood beneath the cargo, is not ordinary wood. It is apitong, or carouing, tropical hardwoods harvested from Southeast Asia, chosen for their immense density and oil content. These woods are naturally resistant to rot and insects. However, modern sustainability pressures are shifting the industry towards bamboo and composite floors. The bamboo is harvested, sliced into strips, boiled, and glued together under high pressure to form a board that rivals steel in density. This transition is slow, a generational shift in material science. The floor you see inside a container today may be the product of a slow-growing dipterocarp forest or a fast-growing grass, both processed into an identical dark brown industrial surface designed to be ignored. Fact 67. The CSC plate, Convention for Safe Containers, is the passport of the container, a small stainless steel rectangle riveted to the left-hand door. It carries the vital statistics, the manufacturer, the date of manufacture, the identification number, and the maximum gross weight. But its most important feature is the ASEP mark, Approved Continuous Examination Program. This acronym signifies that the owner has a systematic maintenance schedule that exempts the container from periodic retesting, allowing it to remain in circulation indefinitely as long as it is visually inspected. The plate is often covered in layers of paint or road grime, but the stamped letters remain legible, a durable bureaucratic promise that the box is safe to handle. Fact 68. The concept of demurrage serves as the financial clock of the port. It is the fee charged when a container sits inside the terminal longer than its allotted free time. It is a penalty for stillness. If a merchant fails to pick up their cargo within 4 days, the clock starts ticking. Fees escalate daily, a compounding punishment for delay. It is a revenue stream born of inefficiency. In the quiet offices of the terminal operators, automated systems track these dwell times. Invoices are generated automatically at midnight. Demurrage is the friction of the system monetized, a tax on the inability to keep moving, ensuring that the terminal remains a place of flow rather than storage. Fact 69. Detention is the twin of demurrage, but it occurs outside the port. It is the fee charged when the empty container is not returned to the shipping line on time. If a warehouse in Nebraska keeps the container on a chassis for 2 weeks because they are too busy to unload it, detention charges accrue. It is a charge for holding the asset hostage. The shipping line wants its steel box back so it can be re-rented. Detention is the economic force that pulls the container back to the ocean. It is a subtle financial gravity, a daily cost, that gently but insistently urges the return of the unit to the circulation of the global blood vessel system. Fact 70. Finally, there is the blank sailing. This occurs when a shipping line cancels a scheduled voyage to manage capacity and maintain freight rates. It is a strategic non-event. The ship that was supposed to arrive simply does not. The schedule, usually a rigid promise, dissolves into empty space on a spreadsheet. Thousands of containers that were meant to be loaded are left waiting in the stack. It is a pause in the rhythm of trade, a silence imposed by market logic. The ships drift at slow speeds or anchor off the coast of Malaysia, waiting for demand to rise. It is the industry holding its breath, a suspension of movement designed to stabilize the economics of the sea. Fact 71. The life cycle of a container ship is determined not by the failure of its engines, but by the cold calculus of the special survey. Every 5 years, a vessel must undergo a rigorous structural examination to maintain its insurance classification. As the ship approaches its 25th year, the cost of the steel renewal required to pass this survey often exceeds the commercial value of the vessel's future earnings. The decision to retire the ship is made in a quiet boardroom, a financial subtraction that reclassifies the floating city from a logistical asset to scrap tonnage. The ship is sold to a cash buyer, usually based on the light displacement tonnage, LDT, the sheer weight of the empty steel hull. It is a transaction of mass, not utility, where the complex machine is reduced to a simple commodity price per ton. Fact 72. The final voyage is a solemn, one-way transit, often performed at reduced speed to conserve fuel. The destination is frequently the tidal flats of Alam in India or Chittagong in Bangladesh, regions where the geography and the tide conspire to create a natural dry dock. The ship approaches the coast during the spring tide, when the gravitational pull of the moon is at its zenith, raising the water level to its maximum height. The captain steers the vessel perpendicular to the shore, aiming for a specific plot of mud that has been rented for this burial. There is no deceleration. The engines are kept at full ahead to maximize momentum. The ship drives itself onto the beach, the hull groaning as it slides over the silt, coming to a shuddering, permanent halt as the kinetic energy is absorbed by the earth. Fact 73. Once the tide recedes, the ship is left stranded, a massive, rusting monolith towering over the beach. It is now a terrestrial object, surrounded not by the ocean, but by wet, dark sand and the smell of ozone and drying kelp. The engines are cut for the very last time. The vibration that has defined the ship's existence for a quarter of a century ceases, replaced by the sound of the wind whistling through the rigging and the distant call of shorebirds. The anchors are dropped, not to hold the ship against the current, but simply to be dismantled. The vessel sits heavy and inert, a dark silhouette against the tropical sky, waiting for the slow, methodical process of deconstruction to begin. Fact 74. The dismantling process begins with the purging, a safety ritual designed to remove the volatile remnants of the ship's working life. Workers enter the dark, echoing caverns of the fuel tanks, pumping out the heavy sludge of residual bunker oil. The air is thick and humid, smelling of old hydrocarbons. They remove the pyrotechnics from the lifeboats, the halon gas from the fire suppression systems, and the batteries from the emergency generators. It is a cleansing of the vessel's nervous system. The fluids that once gave the ship life, hydraulic oil, lubricants, coolants, are drained into drums, leaving the veins of the ship dry and hollow, preparing the steel carcass for the introduction of open flame. Fact 75. The primary tool of the shipbreaker is the oxyacetylene torch, a simple instrument that mixes oxygen and fuel gas to produce a flame hot enough to melt steel. The cutter works his way down the side of the hull, the blue flame hissing as it slices through the metal plate. He does not cut randomly. He follows a cutting plan that reverses the assembly process of the shipyard. He cuts a vertical line, then a horizontal one, creating a block of steel. As the final connecting strip is severed, gravity takes over. The multi-ton section of the hull falls away from the ship, crashing onto the tidal mud below with a dull, wet thud that reverberates across the beach. Fact 76. To move these massive fallen sections further up the beach, beyond the reach of the tide, the yard utilizes heavy-duty winches. These are often repurposed engines from older trucks or even previous ships, anchored deeply into the sand. Thick steel cables, slick with grease, are attached to the scrap block. The winch engine roars, straining against the friction of the sand. The cable pulls taut, vibrating with tension. Slowly, agonizingly, the piece of hull begins to slide, carving a furrow in the beach as it is dragged inland. It is a primitive, brutal application of physics, pulling the mountain of steel apart piece by piece and dragging it onto dry land for further processing. Fact 77. As the hull is peeled away, the ship's interior is revealed like a dollhouse cut in half. The cabins, the bridge, and the mess hall are exposed to the open air. Furniture that was once bolted to the floor is removed by hand. The captain's chair, the brass inclinometer, the heavy watertight doors. These artifacts of navigation are salvaged and sold in local markets as maritime curiosities. The copper wiring is stripped from the bulkheads, pulled out in long, colorful snakes. This non-ferrous metal is more valuable than the steel. The harvesting is meticulous. Nothing is wasted. The ship is unmade, its complexity sorted into piles of brass, aluminum, glass, and timber, leaving only the iron skeleton behind. Fact 78. The propeller, or screw, is a prize of particular value, cast from high-grade bronze or a nickel-aluminum alloy to resist corrosion. It weighs upwards of 50 tons. Removing it requires precise cutting of the propeller shaft. When it finally drops, it falls like a golden coin into the mud. It is polished by the sand, gleaming dully in the sun. This massive, curved sculpture, which pushed the vessel millions of miles through the water, is too valuable to be melted down as common scrap. It is often sold intact to be melted separately for high-value casting, or in rare cases, reconditioned for another vessel, a donor organ transplant for a ship still at sea. Fact 79. The steel plates, once dragged to the hinterland of the yard, are cut into smaller, manageable rectangles known as billets or re-rollable scrap. These plates still bear the layers of paint, the primer, the anti-corrosive, the top coat that protected them at sea. They are loaded onto trucks, heavy, ancient vehicles that groan under the weight. The trucks transport the steel to the induction furnaces located inland. Here, the metal completes its transformation. It is fed into the electric arc furnace, a cauldron of lightning where graphite electrodes pass a massive current through the scrap. The temperature rises to 3,000 degrees Celsius. The solid steel, the paint, and the rust liquefy, becoming a glowing orange soup of molten iron, purified by fire. Fact 80. From this molten state, the steel is cast into new forms, most commonly reinforcing bars, or rebar. The metal that once formed the hull of a Panamax container ship, holding back the pressure of the Pacific Ocean, is now destined to be buried inside concrete. It will form the skeleton of a skyscraper in Mumbai, a bridge in Dhaka, or a warehouse foundation in Gujarat. The molecules of iron remain the same, only their arrangement has changed. The ship has not disappeared. It has been transmuted into the static infrastructure of the land. It sits silently within the concrete, holding up the world, its journey across the moving ocean, finally and permanently at an end. Fact 81. Drifting from the tangible weight of recycled iron, we enter the hushed, sterile environment of the data center. These facilities, often located in nondescript industrial parks in northern Virginia or Iceland, serve as the cerebral cortex of the logistics industry. The building itself is a concrete monolith designed to be inconspicuous and impenetrable. Inside, the primary sensory experience is not sight, but sound, a constant, uniform white noise generated by thousands of cooling fans spinning in unison. The air is kept at a precise artificial climate, 68 degrees Fahrenheit, with 45% relative humidity. It is a clean room environment, filtered of all dust and pollen, a static atmosphere where the only movement is the invisible flow of electrons through copper and silicon. Fact 82. The fundamental unit of this digital architecture is the 19-inch server rack. These are tall, black metal cages bolted to the concrete subfloor in perfect, infinite rows. Within these cages, the servers are stacked like slate tiles, one atop the other. The front of the rack is a constellation of small, blinking LEDs, green, amber, and blue. These lights do not flash randomly. They pulse with a rhythmic, green luminescence that indicates the red-right activity of the drive heads. It is a visual representation of the container's tracking number being queried, a silent Morse code of light that flickers in the cool, dimly lit aisle, unobserved by human eyes for days at a time. Fact 83. The information regarding our container's journey travels between these racks, not through the air, but through silica glass. The fiber optic cables that snake through the ceiling trays are bundles of hair-thin glass strands. Data is transmitted as pulses of infrared light bouncing off the internal walls of the fiber in a phenomenon known as total internal reflection. This light travels at 2/3 the speed of light in a vacuum deep beneath the Atlantic Ocean. These cables rest in the crushing darkness of the seabed, wrapped in layers of polyethylene and steel armor. They carry the digital manifest of our cargo through the abyss, a silent beam of photons illuminating the ocean floor's darkness with the logic of commerce. Fact 84. To maintain the thermal stasis of this electronic thinking, the facility employs computer room air conditioning, crack units. These massive machines stand like sentinels at the ends of the aisles. They operate on a hot aisle, cold aisle containment strategy. Cold air is pressurized into the plenum, the empty space beneath the raised floor tiles. It rises through perforated grates directly in front of the server intakes. The servers inhale this cool air, pass it over their heated heatsinks, and exhale the warm exhaust into the isolated hot aisle behind them. It is a continuous, invisible convection cycle, a silent fountain of conditioned atmosphere that ensures the silicon chips never exceed their operational thermal envelope. Fact 85. In a separate, reinforced room, the uninterruptible power supply, UPS, waits in a state of chemical potential. Rows of heavy lead-acid batteries sit on steel shelves, smelling faintly of ozone and electrolyte. These are the flywheels of the energy system. If the municipal power grid flickers or fails, these batteries discharge instantly, bridging the gap before the diesel generators can fire. There is no switching noise, no click of a relay. The transition is seamless. The batteries exist solely for this moment of crisis. Heavy blocks of lead sitting in silence for years, holding a static charge that guarantees the memory of the supply chain is never lost to the dark. Fact 86. Deep within the spinning hard drives, the data itself is organized into the rigid structure of a relational database management system, RDBMS. The information is not a cloud, it is a grid. Tables and rows intersect with the strict geometry of a spreadsheet. The container number is a primary key, a unique identifier that locks the data together. This structure forbids ambiguity. A null value is a specific type of emptiness. software enforces referential integrity, ensuring that a record of a container cannot exist without a corresponding record of a ship. It is a digital ledger that mimics the strict, unyielding bureaucracy of the physical port, a place where every byte must have a defined coordinate. Fact 87. The physical residence of this data is often a polished aluminum platter inside a hard disk drive, HDD. This platter spins at exactly 7,200 revolutions per minute. The read-write head, a tiny electromagnet on the end of a delicate arm, floats above the spinning surface on a cushion of air created by the drag of the platter itself. The gap is less than 5 nanometers. The head never touches the disk. It hovers, flipping the magnetic polarity of microscopic grains of cobalt alloy from north to south, representing ones and zeros. It is a mechanical ballet of immense precision, performed in a sealed, nitrogen-filled chamber, recording the history of the world in magnetic grain. Fact 88. As the transaction of our delivery ages, it is migrated from the spinning disk to cold storage. This is the realm of the robotic tape library. Here, data is written onto magnetic tape, a medium that resembles the cassettes of the 20th century, but is far denser. The linear, tape-open, LTO cartridges sit in slots in a massive wall. When an auditor needs to check a record from 5 years ago, a robotic arm moves in the silence of the library. It glides along the track, retrieves the square cartridge with a soft mechanical wand, and inserts it into a drive. The data sleeps here, unpowered and unread, a dormant archive of completed logistics. Fact 89. Guarding the perimeter of this digital fortress is the firewall. This is not a physical wall, but a filter, a set of code that sits between the internal network and the open internet. It performs packet inspection on every fragment of data that attempts to enter. It compares the header of the packet against a strict list of rules. Allow or deny. It is a binary gatekeeper. Malicious traffic is not fun. It is simply dropped, discarded into the void without a response. The firewall operates in silence, rejecting millions of unauthorized queries per day, an invisible membrane that allows only the specific authorized language of logistics to pass through. Fact 90. Finally, we observe the ping. Periodically, a server in Nebraska will send a tiny signal to a server in Shenzhen to confirm the connection is still alive. This is the Internet Control Message Protocol, ICMP echo request. It is a digital sonar. The signal travels through the fiber, under the ocean, through the firewall, and arrives at the destination. The destination server replies. Acknowledge. It is the heartbeat of the Internet, a simple, rhythmic pulse that says, I am here. It carries no cargo, no data, only the confirmation of existence. It is a metronome ticking in the background of the World Wide Web, measuring the latency of the planet in milliseconds. Fact 91. Retreating from the digital pulse of the server room, we return our focus to the physical inevitability of entropy. The shipping container, having served its purpose in the high-velocity world of trade, eventually succumbs to the slow chemical reality of its environment. The paint, once a bright industrial blue or red, begins to oxidize under the constant bombardment of ultraviolet photons from the sun. These photons break the chemical bonds of the polymer coating, causing a microscopic chalking of the surface. It is a slow molecular fading, a gradual surrender of color that happens not over days, but over decades, as the vibrant identity of the object is bleached into a uniform neutral gray by the patient, unblinking eye of the sun. Fact 92. Deep within the crystalline structure of the COR-10 steel, a phenomenon known as metal fatigue has quietly accumulated. Every time the container was lifted by a crane, every time it swayed on the ocean, and every time it rattled down the highway, the steel walls flexed imperceptibly. These movements caused microscopic dislocations within the atomic lattice of the iron. These are not cracks that can be seen with the naked eye. They are a silent history of stress, a memory of weight held within the metal itself. The container is tired. The rigid structural integrity that defined its life has been softened by the millions of miles of vibration, leaving it ready for a state of permanent rest. Fact 93. There comes a moment of commercial obsolescence when the logic of the market decides the container is no longer efficient. Perhaps the door hinges have stiffened beyond the tolerance of the terminal, or the floor has delaminated. The container is retired from the global fleet. It is lifted onto a truck one last time, not for a delivery, but for a final relocation to the periphery. It is moved to the back of a storage depot, or perhaps sold to a private owner in a rural area. It leaves the paved geometry of the port and the rail yard, coming to rest on a patch of gravel or grass, far from the ocean, surrounded by the quiet hum of nature rather than the roar of diesel engines. Fact 94. In this new static life, the container is repurposed for cold storage. It sits in the corner of a field or behind a warehouse, immobile and heavy. The doors, which were once opened by the hydraulic power of port machinery, are now opened only rarely by a human hand pulling against the rusted camlock. The interior no longer smells of ocean salt or factory plastic. It smells of dry earth, old hay, or dust. It holds garden tools or winter tires, or nothing at all. It has become a stationary cave of steel, a fixed point on the landscape that will never again cross a border or float upon the sea. The vibration of the engine is gone forever. Fact 95. In this absolute stillness, the oxidation process accelerates. The weathering steel was designed to rust only on the surface, creating a protective scab. But time is patient. Where the paint has chipped away, the orange bloom of iron oxide begins to feed. It is a slow combustion, the iron reacting with oxygen and moisture in the air to form hydrated iron oxide. Flakes of orange rust detach from the wall and drift silently to the ground, settling in the grass like autumn leaves. It is the metal returning to the soil, a gradual disintegration where the artificial strength of the alloy gives way to the elemental softness of the earth. Fact 96. As the physical form weathers, the bureaucratic identity of the object evaporates. The white vinyl stickers that proclaimed its owner, Maersk, Hapag-Lloyd, Costco, begin to peel and crack. The unique 11-digit identification number, the code that tracked it through the databases of the world, fades into illegibility. The container loses its name. It is no longer a specific asset with a value and a schedule. It is simply a box. In the server rooms we visited earlier, a command is executed to delete the row from the active table. The digital ghost is exercised, erasing the memory of its travels, leaving only the anonymous, silent shell. Fact 97. The auditory landscape of the container shifts entirely to the natural world. When it rains, the water drumming on the corrugated metal roof creates a low, hypnotic drone, a brown noise resonance that vibrates through the hollow interior. It is a sound of pure isolation. The wind whistles softly through the microscopic gaps in the door seals, a breathy, hollow sigh. In winter, the snow piles against the sides, muffling the world even further, creating a cocoon of silence. The container is no longer a vessel of commerce. It is a resonant chamber for the weather, amplifying the quiet, steady rhythm of the falling rain. Fact 98. Vegetation begins to claim the structure. Vines, ivy, kudzu, or wild grape send out slow, curling tendrils that seek the rough texture of the rust. They climb the vertical corrugations, finding purchase in the decay. It is a slow, biological siege. The sharp, industrial angles of the box are softened by the green curve of leaves. Roots delve into the soil beneath the plywood floor, anchoring the box to the earth, not by gravity, but by biology. The separation between the manufactured object and the organic landscape dissolves. The container is being digested by the land, pulled down into the embrace of the grass and the soil. Fact 99. On a geological timescale, the existence of the steel is a fleeting moment. Decades turn into centuries. The roof will eventually collapse, folding inward under the weight of time. The walls will buckle. The iron will be completely reabsorbed, dispersing back into the crust from which it was mined. The atoms of iron that once held televisions, grain, and machinery will separate and drift apart, becoming indistinguishable from the red clay of the earth. The logistics of the planet operate on a cycle of rock and ore, a loop far slower and more permanent than any shipping schedule, a cycle where everything that is built eventually returns to the ground. Fact 100. We reach the final state, absolute stillness. The motion has ceased, the data has faded, the ship has been unmade. The container is Earth. There is nothing left to move, nothing left to track, and nothing left to count. The complex systems of the world continue to spin, but this specific point of matter has found its rest. It sleeps in the dark, heavy and quiet, covered by the blanket of time. The noise of the world recedes into a distant hum, and then into silence. There is only the dark, there is only the quiet, there is only the sleep